In this video, I will show you how I refactor a typical Jupyter notebook to improve it in three main ways. First, in the readability. Typically, notebooks are long and hard to read with a lot of implementation details exposed to us. And in this video, I show you how we can encapsulate them in smaller functions that read like a story. So the entire notebook now fits in, essentially a page, where in the past you would be forced to read, hundreds of lines of code to understand what's going on. In this case now, you can understand it in maybe a few minutes just by reading the functions. Second, we improve it by adding unit tests. So typically notebooks are hard to test. Like if I was to introduce a typo or change this number here, I would not get any feedback to tell me that I've done something wrong. And on the other hand, if I was to break something here, say I forgot to drop name, the test would immediately fail and give us immediate feedback. And so through this refactoring process, we're going to improve the testability of our code base. And the third thing is, generally, we're going to take it from a place that is hard to maintain and error prone to a place where it is easier to maintain and less error prone, by a combination of the things that I've just talked about. Having single responsible functions that are easy to read, having unit tests, and a few other practices that I will show you in this video. We're going to improve the maintainability of our data science code and make it evolvable so that we can grow it and evolve it as time goes on. This video is a summation of a lot of the other concepts that I've shared in the other videos in this series. Things like how to write a unit test, how to use your IDE to improve your productivity as a data scientist, and how to use Docker, and so on. So if you find that I'm going too fast in this video, I'm introducing too many new concepts, feel free to pause this video and check out the other videos in this series and come back to this. I've kept this video in this long form style because I want to show you a series of coding habits that I think are good for any data scientist or programmer to have. And in this next hour or so, we're going to take this notebook from this state into this state, and along the way, some of these habits, I pause and explain what it is, why I do it, and I hope that's useful for you. Let's get started. So the first thing we'll do is to run the tests in watch mode, and I've already done this. But just to recap, the command is to say nose test with watch, red nose for the colored output, and no log capture to kind of mute some of the noisier output of the test runner. So that's done. And now we will identify a block of code that can be extracted into a pure function. Actually, sorry, this is a part of the refactoring cycle. So let's do that. The first code block we'll start with is this one. So we initially identified duplication as a code smell. One of my guiding principles in programming is to let duplication live. It's better to have duplication than to have premature abstraction. And there's a great talk by Sandy Metz, which I will link in the comment section below, that talks about this in greater detail. But essentially the idea is that if we keep our code so dry in that there's not one single line of duplication, our code will become so hard to read because everything is abstracted away. So premature abstraction will cause much more problems than duplication. So when I write code, I will live with this with no problem. It will be fine to have such duplication at first, let it live, let it evolve, and then we'll start seeing a pattern emerge in that we always want to train a model and score it. And when this duplication is explicit, it now presents itself as an opportunity to refactor. And so it's okay to have duplication, and the pro tip or the trick is to make it as explicit as possible. If we have duplication, make it look identical so that we can start seeing opportunities for refactoring. So let's refactor this into a method. In a later example, I will write the test first, but since we are getting started, getting the hang of refactoring to functions, I will start with a function first, and then I will write a test for this. I like to begin by thinking about the input and output to this block of code. So if I had a function called train model, what would be its input? So clearly this model parameter algorithm will be an input, and what would be the output? We will need the model itself. That is the behavior of this block of code. It creates an object called SVC, and it will also return an accuracy score later. So we probably need to return that as well. And what else might it need? For testing purposes later on, we will need to inject this training data. So I will now pass it in as well. And it appears that it also needs the test. So I will add that in. And let's define this function. And let's cut this out. And this is just date code. It's not doing anything except in the notebook it printed out to the output, so we just remove it. So this is essentially the behavior, right? So let's make it work first and make it better. My IDE is helpfully telling me that these are undefined variables, so I will need to pass it in as a function parameter. Same for xtest. And that's the contract of our function. We need to return a model and the score, right? So return SVC and then the score. So the test is passed, and you realize that when I was extracting this out, I wasn't concerned about other code smells like this badly named parameter or this badly named return value. So when our tests are failing, the first thing we want to do is to get it green. So this is just a generic model class. So I'm going to press function F2 to rename it to a generic model class. And so that we can later on pass in the k nearest neighbor as well, right? And one thing I realized was this quark. This gamma option is only for SVC, so there's probably needs to be another parameter for. So if I'm going to use SVC, I might want to pass in different set of keyword arguments. So this would come in here, and in Python we will receive that as a quark and pass it down to wherever we need it. And now it's happy again. And we can use it to replace this block of code. So now we have k nearest neighbor instead, and the keyword argument will be n neighbors. And this clearly will be KNN and accuracy KNN. And now this block of code can go. And now let's continue refactoring this one. So model class is generic. SVC clearly is not SVC anymore. It's just any model. So let's press function F2 and rename it to a model. And again, our IDE has helped us with this. And accuracy is not about SVC anymore. Let's press F2 and replace it with the accuracy score. And I'm quite happy with that. So I will now extract this to the right package and write a test for it. Well, I'll call it model training. I will move this method first. And our test is helpfully telling us that on this line 101 of our refactoring starter code, this is not defined, so we have to import it. And our test is happy again. And now we're going to focus on writing a test for this. I'm going to close the things that are not related. So as I mentioned in my other video, the most important thing in a unit test is the test description, because when you write it correctly, when you describe what we are testing, what we're expecting, the rest of the test kind of just writes itself. So here we are saying that this function called train model will return a model instance and some accuracy score. And then we can start writing assertions around this idea that it would return a real instance of the model and yeah, a score. I've been on several projects, so that's why I can almost memorize this test syntax by heart, but it's clearly very hard when you're just starting out learning about testing, learning about machine learning. So in my past projects, I usually just refer to existing tests in the code base, and usually that helps me figure out some of the syntax which I may not remember, and I shouldn't remember or memorize all these things. And yeah, if you need help referring to some of these test cases, you can refer to the Clean Code ML repository. There are some sample test cases that you can take from here. All right, let's come back to writing this test. The test runner is telling us that in line 6 of this test, this train model is not defined. So let's fix this test.
From model train, import train model.
And it's saying we are missing 4 positional arguments, model class, this and that. Okay, so for testing, it doesn't matter what we are actually using in the notebook, so we can use any model really. So I will use logistic regression.
So let's see, so scikit-learn linear model, is it?
So let's import it. And the next thing we need is X train, Y train, which is a 2-dimensional array and a 1-dimensional array, and a test data set. Okay. Now we got a warning about this, so let's specify a solver to silence this warning. All right, let's pass it in as a quark, keyword argument. All right, now without any assertions, the test passes. So now let's actually write the test case. Let's see what assertions we have for class names. And yeah, there's one called assert is instance. So what do we do with this? We pass in an object and a class. So our object is this sum model and the class is logistic regression. Okay, that's good enough for us. And we can assert that the score is non-zero. What do we put in? A and B, first and second, assert that A is bigger than this. So our score should be greater than 0. And just out of curiosity, what is this do we have? Now I'm wondering where the Y test is coming from. So maybe we found a bug in our... okay, so we found a kind of a, I want to say bug or some weirdness in our code. We have this X test that we take in and we get a Y pred, but then in our original notebook, we are scoring ourselves based on X train and Y train. So we're not at all using the test or validation set. So this is a bug that we discovered through writing the test. So yeah, this is something I might write a to-do and come back to this later to actually validate this using test data rather than training data. So yeah, I'll write it on a to-do and kind of get back to this. But for now, it appears that we don't need it. All right. So we have now 2 failing tests because we changed the contract of this one. So our first priority is to get the test green. Let's remove the date code that we don't use. Okay, 1 test passed and the other test is in our functional test. Well, we can also click here and go directly here. And it's in our source code here. Yeah, X test is not used. Okay, tests are passing. We have a function. We have a test for that function. And I think we're good to make a commit. We fix this code smell, so let's remove this. So I forgot to check off some of these tasks, so let's do that first before we commit. Alright, so we've identified the block of code, we've written a test for it, train model test, and we've extracted into a module, defined a function, our test the passing. When I first wrote this list, I said in the notebook, replace the original code block with the new defined function. That's what we've done here. Except that it's not in the notebook. So I check this off. And we didn't need to restart and run the entire notebook because the characterization test was doing that for us. Every time we change some code, it's going to run again, run the whole code that was originally in the notebook. So yeah, we just kind of mark this as done. We've refactored some more, and now we're going to commit our changes. So let's go through the checklist with a new module, with a new function. We have a new test for our train model code. And we've removed duplication. This is the essence of it. All right, let's make a commit. All right, extract model training code block into a function with a test. And let's go on to our next task. When I work, I like to make sure that there's not so many open tabs and unnecessary noise so that I can keep myself focused. And make sure my test runner is always in sight so that I get immediate feedback. All right, the next thing that I would do is to refactor this code block. So let's practice again the same steps that we had done for the previous function. We will extract this block into a function inside this same file. We will replace this implementation detail with that new function, and then we'll write a test for that function. In a later demo, I will show you how you could write the test first, and then replace or rewrite the implementation. But for now, yeah, we will kind of get used to the rhythm of this refactoring by getting more practice with it. So I'm going to call this function extract title from name.
Alright, so this is the block of code that I need to take out.
We will need a data frame clearly, and it would return a new data frame with the new title column within it.
So extract title from name, taking the data frame, and our implementation, I've just pasted it back here.
And now this is working well and fine. So before making any more improvements or changes, I would add a unit test for this function. So let's again move this to the right module first. This looks like the first of many data preprocessing code for feature engineering. So I'll just call it data preprocessing for now. Again, I will move the function to the right place. And we have a failing test, so that's our first priority, is to fix that. And our IDE has helpfully told us where the problem is. And it's highlighted in orange here, saying that this is undefined. Okay, it's happy now, and so let's write a test for this. Again, I will close all the things that I don't need, and let's write a test. Later on, we might break this up into separate folders, and that may help the readability. But for now, let's focus on writing the code and writing the tests, and later we can move the files in a different commit. Right. So let's look at again the input and output of this function. Right. This function expects an input of a data frame, and this data frame must have a name column. And what is the output? It is another data frame with what it had originally with a new column called title. All right, so that will be essentially my test.
Extract
So that is what this test is going to do. This function extract title from name. Should return a data frame with a title column derived from main column. Clearly, there are many ways to skin a cat or many ways to define a test function. Sorry to all the cat owners or cat lovers. I have a cat myself, but yeah. There's many ways to define this this test name. For me, this is how I've gone with it. So feel free to name it whatever is clear to you. All right, so we are going to invoke our function.
So from data, extract title from name. It's going to need a data frame, and we're going to
find a data frame shortly. Okay, we need pandas. I'm seeing from the lack of IntelliSense that I don't have PD in scope.
Right, PD.data frame. It needs a name column, and for now let's just leave it empty first.
And I want to flesh out the shape and skeleton of this test before filling out with the contents or the body.
So this is going to give us an actual data frame, and that's what we're going to assert on.
As I mentioned in my other video on testing data frames, we can use this method from pandas to assert on data frames. So we can assert that the expected data frame is the same or is equal to the actual data frame. And now we begin to flesh out what is the expected data frame. It will have a name and it will have a title. This is now failing because our implementation needs some data inside here. So I might just take it from the actual data set itself so that it's realistic. Let's take this name. And we know that we are expecting Mr. And this test should pass on first pass because we've copied the implementation. All right, and this is where we can begin to flesh out the test case to cover all lines of code. And why it's so important to do that is because we're now starting to depend on unit tests as a feedback to see that everything works. If we have an incomplete test case that just tests Mr., but in the implementation there are many other behavior that we haven't tested, then should these one day degrade or regress, maybe somebody deleted this line or maybe made a typo here, we're not going to get any feedback from our test. So it's very important that all unit tests cover all of the lines that are being invoked. So now I will flesh out this test case to be more complete. So now I've expanded this test case further and it covers all of the lines of code. So it covers Mr., Miss, Mademoiselle, and all the rare titles, Lady, Colonel, Major, Jonquier, and all of that should become rare as is the original behavior in the notebook. And I've just used some white space and organize the expectation, so you can see that this maps to this and this Mademoiselle maps to the third thing inside here, which is Miss. Yeah, and if one day this were to degrade, I accidentally made a typo or intentionally changed this, we get immediate feedback to say, hey, you've broken behavior. And now this tells us to step back and see, okay, what am I treading on here? Let's be more careful about how this is being changed. If it's an intentional change, I would go and change the test case to make sure it reflects reality. If it's an unintentional change, then I would just kind of step back. Yeah. All right. So let's come back to the main program. Okay, we've improved this. Let's remove this comment about the code smell. And let's make a commit. We have a new function. We have a test for that function. And we have made the notebook a little bit better to read. So you can use the command line to comment, or you can also write it here. So extracted. All right. The next thing is about drop. So there's duplicate responsibility. I'm sure you've heard of single responsibility principle many times, where one function is responsible for doing one thing and not many. And in this case, we have many places that are responsible for dropping columns. So that feels awkward to me. Like there should be one place where unneeded columns are dropped. So I might just slide these lines down altogether. And this is my main reason for wanting to use an IDE, because doing this is so hard in a Jupyter notebook. Okay, so I will just slide line this, all of the DF drops together.
Is there any other drops? Okay, Fairbairn is the last one.
So now when the duplicate responsibility has been fixed in the sense that it is all together, now you start seeing opportunities for refactoring, right? You can all of these should just be one line of code to drop unused variables. And again, our characterization test is helping us in giving us immediate feedback. If I had forgotten to add or drop one thing, let's say I forgot to drop name, the test will give us feedback to say, you've actually dropped out, missed out behavior, and that's the value of that characterization test again. All right, so we've fixed this code smell, and I don't think this needs to be extracted into a function because pandas already gives us this function to drop. So I might just leave it here for now. And since this is a logical commit, I will commit it by itself.
So consolidate.
Consolidate dropping of columns into a single place. So coming back, what's the next thing that we can do? This is an easy one, so let's start with this. There's an expose internals here. If this was extracted into a function with a sensible name, we can just read that method name and know what this is doing. We don't need to read and understand the how and spend our mental resources to know what this is doing. Right. So if you're wondering what a sibsp is or parch, I had to jump into the data set, data dictionary, and read, okay, this is number of siblings and spouses, and this is number of parent and children, and I have to solve this puzzle once. So my life philosophy or coding philosophy is that you should try to solve puzzles once. If I've solved this puzzle before, I'm going to make sure the next person that comes after me does not need to solve it again, because solving puzzles is expensive, it is a distraction, it is stopping you from what you actually want to do. So let's solve it once so that the next person doesn't have to do it anymore. So the behavior of this is that it takes in these two original columns and it adds a column called is alone. By default, it is 0 in that you are not alone. But then if your family size is 1, and what is family size? It is the number of siblings and spouses plus parents and children plus yourself. If your family size is 1, then you are alone. Okay, so it's a little bit kind of a hacky code. So anyway, let's make it better. Let's think about the output and input of this function. So it's going to return a data frame with a new column, and it's going to add a new column called is alone.
So
and it's going to take in the original data frame which has these features. All right, let's maybe try TDD for this one, since it's quite a straightforward example and it's easy to demonstrate. So TDD means test-driven development, means we write the test first and then we write the implementation. In this case, the implementation is already here, but having to write the test first, I think, is useful practice for us. to kind of get into the habit of writing the test first.
Okay, so test add is alone.
So that is what we're planning to do. Our function add is alone column should derive a new column based on the number of spouses, siblings, parents, and children.
So,
we are going to define this function shortly, but let's just assume it's there.
so we know there's a column called parch, and we know there's a column called sibs. And our expectation is that these columns will still be there, and there will be a new column called is alone. Alright, so looking back at the original data, these are numbers, sibs and parch, so let's work it out.
Let's work out the examples. So if I have no parents, children, or siblings, spouses on board, I am alone. And let's get this test to pass first, and then add more examples if to make sure we cover all lines of code. And okay, let's write the expectation as well.
Assert frame equal, the expected should be equal to the actual. Alright, so let's fix this failing test. This is not defined, so we need to go to this data preprocessing module and define a function. If you remember, it takes in a data frame, and let's do nothing first.
Okay, this error is coming from line 58 of this. I'm going to click on this and go there. Control G, go to line 58. Okay, I need to import it here. Right. All right, so now this is a little bit noisy because there's kind of a gap. We are currently working on this. It's not finished yet, but this characterization test is kind of complaining about something that we are going to fix shortly. So for now, I'm just going to skip the test. So we can skip test by doing this. All right, so now this is the actual failure that for this new test that we've written. We expected a data frame but got none type instead. That's because we haven't returned anything. So let's just return a data frame just to see. And there's a shape mismatch because we had expected a new column, but we haven't done anything. So we need to go and add this is alone column, right? At this stage, since the implementation is there, I will just copy it. And this is interesting now. Our test helped us find kind of a new problem or smell with our code base in that we have this feature called family size. It's added to the data frame even though it's kind of private to this method. Nobody else uses this family size. And we can verify that in the main notebook. If we look for family size, we don't use it except that we drop it as a side effect, right? So this is an opportunity for refactoring. This has got nothing to do with the original data frame. We just need to be a series, right? So let's just call it a local variable. And it's now passed because we only have one test case or test scenario in that if we have no partners, no nothing, we are alone. So this code is tested. But we also have to test other cases.
So for example, if I have one parent or children and no siblings, then I should be not alone. So here I should be not alone. And the test pass. And yeah, I will just kind of repeat this for the other cases. And in this case, I have one sibling as well, so I'm not alone again.
I think that covers all of the cases. And I'm quite happy with this. We could refactor this some more. yeah, but for this demo example, I'll just leave it here. Now we unskip this test. Okay, and we found a bug that I just introduced. Now we no longer have a family size. So we've improved that code in the function, and we need to improve it in the main method as well. Now this temporary variable is not used. We don't need it. All right, let's make a commit.
Add a new function. We have a test for it. And we've improved our code main notebook just a little bit.
All right, so now let's tackle a hard one. This is a fairly complex example, and it was pretty time consuming to come up with the solution. So in this demo, I will be lazy and copy and paste a solution. So let's dive into it. I'm going to call this function convert continuous variable to categorical, and it's going to take in a series, convert into this number of beans, and assign it back to this age column. This is not good. I will probably rename this to age band later, but for now, let's preserve the behavior here. All right, and the test case for this, I will start with a simple example. I spend some time to understand this problem a little bit. So given a series of, let's say age, 5, 20, 10, 25, if we have n bins of 2, this is the cutoff point for each one. So number 5 would be rounded up to the first bin, number 20 will be put into the second bin because it's above the band, and 10 will be the first bin again, and then 25 will be the second bin because it's not inclusive of this. Again, the implementation or how it works doesn't really matter because it's an incidental or accidental complexity for this problem. For you, probably knowing this will not change how you solve your problems. I just want to show you how the refactoring process would have worked. So I have a test for it, a simple test case, so that it will fit in my head. And I have kind of refactored the implementation a little bit. And now this preserved that behavior, and we no longer have that temporary age band variable, and our characterization test is helpfully telling us that. So let's remove this, otherwise, yeah, it will blow up. Okay, and this happens again later for fair band, and so yeah, we can do that as the same part of the same refactoring. But for now, I'm not happy with the fact that age band is actually hidden inside this age column. 0, 1, 2, 3, 4, 5 is not age. It's actually age band. So that's what we are representing here in this column. Rename this to age band and replace it in various places and drop age instead. This is a fairly complicated change, and we are about to undertake another equally complicated commit. So in this case, I will make a commit first, so that if I should blow up halfway, I can simply, come back to a checkpoint. So let's first commit this one.
Okay, we have a new function. We have a test case. And we've improved the code base slightly without this puzzle that this person needs to solve. Now the person just needs to read convert continuous variable to categorical, and I'm taking age, converting with 5 beans, and we'll get age band. That's much more readable.
Create function to convert numerical column to categorical column. Since this logic is going to be used at another place, and I don't have enough confidence about this function yet, so I will add another test case to make sure that I cover all kind of data ranges and number of bins as input. So let's add another test case. So in this test case, again, I've kind of took out a pen and paper, worked out that if I have this series and I give it this number of beans, these values would create these beans and bucket each of these numbers into 1, 2, 3, 4, 5. So I've tested, in your refactoring, if you encounter that there's a kind of big chunk of logic that that is doing a lot of things, don't hesitate to stop and kind of make sure that you cover all of the edge cases so that you can slow down a little bit so that you can move faster later on and make sure that no bugs are introduced when you change code here. All right, so let's cash in on our investment. We have invested time in refactoring this implementation into this function. Let's use it here.
This block of code, and now instead of having fair, instead of having age, I will have fair, and the number of beans is 4, it seems, in this case. And
yep, fair ban is not found in X's because we didn't create it, so we need not drop it. And everything still works, and we can now take the next step to rename this to be more sensible. It's not really fair anymore, it's fair ban, right? And we need to drop this fair feature because that's the whole point of this feature engineering, right? And I like to put related things together. So let's move this conversion together. Although here there is also related logic here. Okay, so fair ban also needs to be changed here. So now it looks more symmetrical. Things that were kind of in two places are now grouped together, and this might suggest to us opportunities for refactoring later on. But the first step is to put it related logic together. All right, let's make a commit. Okay, replace fair ban logic with this function. The next thing in our code smells list is the encoding of string variables into integers. So this happens in a few places. This is 1 and this is 2. And actually a hidden third place is here. So if you see here, we are also passing a dictionary to convert title from string into integer. This was a little bit hard to spot because the symmetry isn't there. Just by looking at this, you can see clearly that these two are the same, but the visual symmetry was lacking here. This is what I mentioned earlier about making duplication explicit. So if this was explicitly put here, then it would have been very obvious that this is a chance for refactoring. So the first trick to refactoring or extracting function is to make duplication explicit. And then this duplication presents itself as an opportunity for refactoring. All right. So let me just verify that title mapping indeed is not used anywhere. And indeed, this is the only place. So I can do a refactoring technique called inline variable. So I inline this variable and get rid of it. And our characterization test tells us that everything's still okay. And let's go on. And here through refactoring, we've discovered another bug in that this is not how we should convert a categorical variable into numbers. We should instead do something like one-hot encoding. But I'm going to do one thing at a time. So when I refactor, I'm not going to change behavior. I'm going to live with this buggy or wrong behavior. And when refactoring is done, we put on our other hat of adding a feature, right? Adding a better encoding feature. So this is kind of a key principle in refactoring. When you refactor, do not change behavior. And when you're adding code, don't think about refactoring yet. Just do one thing at a time, and our brains will generally work better that way. Another refactoring technique that works well for me is to group related logic together first, and that presents itself as a code block that can be extracted into a function. So that's the thing about duplicate responsibility, right? We're actually doing one thing but doing it in many places. By sliding these lines together, that presents itself as a function that's doing one thing that we can ship out into another function. So let's do that and slide it together. The catch here is that you have to be careful of hidden state in Jupyter notebooks, because this code is written in the sequential order like this, so it might break something if I move things out of order. So we just have to be careful of that. Now this is much better. We know that this looks clearly like a single responsible function that will convert categorical variables to numerical variables. So again, let's establish the contract here first in some pseudocode. All right, so I will call this function add categorical columns. We might think of a better name later, and we can simply rename it with a single keyboard shortcut. So for now, I'll live with this name. All right, so what will you need to know? You will need the data frame, clearly. And perhaps the mapping can be internal or private into this function. So this function will just take care of how it will convert. Like Mr. becomes 1, Miss becomes 2. I don't need to tell it from the outside. And later, should the implementation detail change, it will only change in one place inside this function and not from the caller. So if I were to change this to one hot encoding later, that will kind of take care of it within this function. And I have one place to change code. All right, so I won't change this file at the moment so that the characterization test is left alone. I will add a test that tests this behavior, each one of them, and move the implementation bit by bit over.
Right, so dev test should convert.
Right, so add our function add categorical columns should convert title column to numbers.
So it's a function, it takes in a data frame and returns a data frame, and let's call this the input data frame. Let's find out what the mapping is and add a test for that. So Mr. becomes 1, Miss becomes 2. And I'll just jumble up the order, just for fun.
So Mr. becomes 1, Mrs. becomes 3, Miss becomes 2, Master becomes 5. No, Master becomes, no, rare, we have rare first, rare becomes 5, and Master becomes 4. All right, so we assert that this is the expected and against the actual. So since this is just one line, I might inline it instead. All right, and now we need to define this function.
Takes in a data frame, and it will know to convert the title column and assign it back to itself and return the data frame.
Awesome. And let's continue for the next 2 lines. And let's add a test first.
If we had an embarked column, and the values are S, C, and Q, it will be mapped into this. So SQCSC will be SQCSC. So 0, 2, 1. 0, 2, 1, SC, 0. And now our test fails because it didn't do any conversion. It is expecting a number, but it's still got an object. It is a string. No? So let's fix that. We can move the implementation into our function. Assign it back to this column. And test passes. And let's repeat. Now for the last one. Female and male. What is it? Gender. Sex. Okay. yeah, okay, we have to follow this. So male, female, female, male. So that becomes 0, 1, 1, 0, 0. And again, our test fails because we don't have that implementation yet. So we can move this in. And now we have encapsulated this behavior inside a function. We can now use it here. Import it, it's saying it's not defined in line 37 here.
Awesome. And to see the before and after state, I will show it to you here. We used to have duplicate responsibility, like this conversion of strings into categorical numbers happening in 3 different places, and it's hard to read and coupled with some other logic. Now it's cleanly put inside this single function, and this function is tested. So should one day I mess up something, immediately within seconds I'm getting a feedback to say, hey, I've messed up something. So that's very useful. And more importantly, if I should change the implementation strategy of how I implement this conversion, maybe I want to use one-hot encoding, I want to use some other way, I only need to change it in one place. I didn't need to update it in here, here, and here. So that's a big win. Let's make a commit since we've completed the refactoring cycle. So we added a function. We added a test that covers all the function, and reviewing commits is reviewing the changes before committing is a very good habit, because you might find things like this stray comment and some to-dos here and there. So let's remove that. And we've cleaned up this a lot. All right. Okay. Extract conversion of categorical string variables to numerical categories into a function. All right, let's close everything again and start here. What can we do next? I like a quick win now. So there's just some extra white spaces. I can just clean it up. I have a stray df head which doesn't change the output of anything. Some white space here. I can also commit that quickly. Shift Control G to open this up. Okay, so add this. All right, and the last thing on our to-do list is the duplicate responsibility of how we fail nans. Let's understand the problem a little bit. We have fail nans in a few places with different strategies. We fail NA firstly by replacing with 0, hard-coded 0. The second thing we do is to fill the NA with a mode. So this thing called embarked, we just take the most frequently used point and use that. And now the third strategy is to use the median. Now, that feels like 3 different things, but also a single thing of filling nans, which can again like this function just kind of encapsulate that complexity. So let's take it into 2 steps. Let's remove this explicit duplication. So you can see that again here I'm making a duplication explicit by using white space to see that, hey, this is exactly the same thing. So this can be one function, and let's come back to define a second function that encapsulates all of this fill NA logic. All right, so what should the test be, or what should the contract be again? So we have probably we'll receive a data frame, and maybe this can be called fill nans with median. And clearly it will need a data frame and possibly a list of columns to fill nans with. So it might look something like this. Okay, I'm quite happy with this contract, so I will write a test for this.
Fill nans with median.
So for the test, I like to decouple it from the actual data. So I might just call this anything.
So our input df will need these two columns. 0, 10, 20. 0, 1, 2.
And the median for this will be 10. The median for this would be 1. And let's put a NaN value here. And our ID is helpfully telling us that NP is not defined. So let's import that. Our expectation. Now this NaN would be replaced with 10, and this NaN would be replaced with 1. And I might just add one more row or one more column that we won't replace. And so this will make it into our output data frame, but with the NaN intact. So that's to test that we only convert what we tell it to convert. All right, and let's write the assertion. I like to use white space here to denote the arrange, act, assert of unit tests. Otherwise, if it was all clumped together, it's kind of hard for the reader to know what is actually happening. So this white space kind of highlights that this is the main thing that we're doing. All right, just a small aside. Let's implement this function. Okay, it's past the 80 line thing, but I may come to do linting or formatting later on.
Columns. And we already have the implementation, so it looks something like this. So for column and columns, do this. Oh, sorry, it's not column, isn't it? And read.
So our test is giving us immediate feedback to see what's wrong with this function. We expected a data frame, but we found a none type instead. So it reminded me I forgot to return something from this function. Okay, so D types are different. Here I've clearly in the implementation replaced it with median, which may be a float, may not be a float. But in this test, so happens that everything are integers. I care mainly about the assertion and not so much whether it's a float or not. I will now tell pandas testing assertion statement to say check D type false. So don't check the data type here. And now it's happy. So we can get rid of the interim comments. And now the tests are passing, and we can replace this with this. So now the value of having extracted this function is that next time if there should be another column that I want to fill NaN with, I simply need to extend it here and add whichever column that is. Maybe that would be title or embarked. Whatever that may be, I didn't need to kind of copy and paste this and say title, replace with this, replace with embarked. So you can see that there's the value of extracting something into a function that will reduce the kind of duplication or visual noise in the code base. Also, if one day I decided to change my how I fill NaNs, maybe I want to use mode instead, I wouldn't need to go and copy and paste in multiple places. I should only need to go to this function and change it in one place. All right, so there's a value of extracting into a single function. Okay, we fix this code smell, so let's remove it. Let's commit this and come back to the general catch-all fill NA method.
Let's review our commits. Okay, we found a stray comment, so let's remove that. We have a new test case. and we have simplified the implementation.
Just commit that, and again, close everything and start afresh. Now my next target is the fill nans. So I will again do the slide line to move everything related to fill NA together and then extract it into a function. So this really is one block. It's not being used anywhere else, so I might just inline it to make it obvious that these two things are related. And I will slide line. In VS Code, you press Option up down, and with all the nan values together. And then this, it presents itself to me as a code block or a function that can be extracted away. So let's again think about the contract. So we want to output a df, and this is the function, and maybe I just pass it a df. At this point, I'm happy to move this logic just as is, move it all out into this function, so that the function knows that it needs to replace title, knows that it needs to replace title with 0, knows that it needs to replace embarked with the mode. That will do the job for now. And should this evolve to, maybe I need to fill more than just title, right? Maybe all columns, all numerical columns need to be replaced, or all string columns need to be replaced with a mode. I don't know that yet. So I don't want to premature abstract it into a perfectly designed function that will handle all kinds of nans. So I'm just going to preserve existing behavior inside a function and add a test for it and just leave it there for now. And yeah, not to overcomplicate things at the moment. I want it to read like a story. I want you to be able to say, okay, first I load the data, I extract the title from name, I add categorical variables, I convert this and that, I fill nans, and I go on. So I don't want to break the story halfway and suddenly give a lot of unrelated implementation details for the reader and the maintainer. So for that reason, I will extract it into a different function. All right, so that's our test. We have an input data frame with some nans, and it will replace the nan with 0 after invoking this method. All right.
And I'm going to copy the implementation logic over here.
And now our test is telling us we expected a data frame but got none type, and that's because I forgot to return the data frame from this function. And again, the D type is something that doesn't matter at the moment. I don't care that it's float or integer, I just care that the values are correct. So I would say check D type is false. And our test passing. Let's go on to replace embarked with the mode.
And let's add a test for that. So I'll set it up such that 2 becomes the mode, so that we will expect 2 instead of nans. Alright, so our test is failing for the right reason. We expected 2, 2, 2, 2, 2, but we got nans because we haven't replaced nans for embarked column yet.
And it's happy now. And if this is hard to read, I find that it's hard to read now, I will extract it into a local variable. So when you work with IDEs, you have some tools that can help you with extracting variables. So I will use this extract variable and say this is called okay. And again, I like symmetry, so I like to keep using the square brackets instead of suddenly changing to a dot notation. Okay, so we've covered this line, and the next thing is to fill nans with median. So this suggests to me that there maybe should be a parameter where I can pass this in so that in a test code I don't need to set up actual data. I can maybe just pass in columns, median columns. And later on, there might be one for, modal columns or, zero columns. So we can evolve that later if the requirement comes. But for now, I would just write enough code for what we need at the moment. All right, so now this function should now have this median columns parameter.
Let's say it's going to be some column. So let's take this value. And if we have then and then, we will expect 10 because 10 is the model median value. Now let's get this test to pass. Or actually we can just delegate it to this function that we have and pass in the median columns.
The iteration through each column is taken care in this helper function that we wrote earlier. And now I think we're in a good state. We can remove this and have this instead. Awesome. And now we have this. Okay, let's make a commit and finally clean this up. Let's review our commit.
We have a new function called fill names. We have a test for it. And we've simplified the notebook just a little bit. All of the fill names in 3 different ways are now into a single function. And
again, let's close everything and see what else we can refactor. Here I'm seeing two things. There is drop happening in two places. I must have left this out just now.
so let's just move it closer together and see that all the tests still pass. And now there's no reason why we shouldn't put that in one line. Okay, that works, so I will go ahead and make a commit.
If you recall earlier in the video, we realized that in the original implementation, we were scoring our model using the training dataset. So that's clearly a bug. Let's fix that first and then refactor because I think it's just easier. So when I'm taking off my refactoring hat now and I'm adding a feature to make this function validate on the validation set. Once I've done that, then let's refactor. When I was preparing this, I looked at the data and I realized that test.csv actually does not have the survived column. So it's not possible. We don't have the ground truth label here. So we're not able to use this as a validation set. So what we will need to do is to take train df and train test split this into a train and test set. So I'm first going to start by removing unused code. So this thing called xtest, we realized that it's not used anywhere. Xtest comes from testdf. So let's see who is using testdf. So again, we load it, we concatenate it into this data frame, and we find it again. But again, there's no ground truth here, right? There's no label, so we can't do anything with this testdf. So I'm going to remove these 2 lines of code as well. And this unused testdf, I'm also going to remove it. And now we see that df is the same as train df, so there's no need for this train df intermediate state. And here again, we have this thing called train df. There's no need for this anymore because remember the NA comes from the test CSV, which has no survived column. So I think we can just go straight into working with data frames. And again, our characterization test is our test harness here. It's telling us that what we're doing is okay. Lastly, this is not really train, it's just X, and from here we're going to split into X train and Y train. So I'm going to rename this to X. Press F2, X. So I'm going to press F2 to rename variable and realize that it will change it at all places for me. So I don't need to do one by one. And again, that's the big perk of using an IDE. All right, so I'm happy with this refactoring, so I will make a commit and then come back to do the train test split.
So review our commits. We remove the unused test.df. Let's simplify this by removing date code. I think that's a code smell, which I covered in the code smells video, date code. All right, so remove unused test to test.df. Test.df. Okay, remove unused code related to test data set without the target variable.
At this stage, I don't think there's a need to extract this into another function. It's already reading quite clear in a line. So I will live with this. Let's summarize this, what we have right now. We load the data, we do some feature transformation, we extract title column from name, we add categorical columns, we add a column called isAlone, we convert continuous variables into categorical variables with this number of beans, we fill the nans, and we drop unused variables, and we get our x and y, and we train a model. So you realize this reads like a storybook, right? This, within a minute, you can understand what's going on. And if I wasn't sure what this is doing, I can simply go to the test case and see what's going on here. Read the test description, read the data, and I can know what is the input and what transformation this applies and what output I will get. And if I really want to know more about this, I can jump into the function definition to see how it works. But otherwise, if I'm doing something else, I need not concern myself with the how. I don't need to understand the how, because the abstraction, in other words, this function tells us the what. It tells us what it's doing. And this reads much easier. Within a minute, you can kind of understand what's going on, as compared to something like this. When I first started this exercise, it took me more than an hour, probably half an afternoon, to understand what is going on, and what is noise and what is the signal. So when we refactor into functions with tests, this is the benefit that we get. All right, and so let's just do the final thing to improve our code base to actually spit out a score that is based on the validation set rather than the train set. So to do that, we will use train test split.
So from sklearn, I think it's called model selection, and got train test split. What is it taking? Arrays.
Oh, here's an example here. So again, that's the benefit of using an IDE. I didn't need to jump to another website to understand this. So we call train test split, we pass in x and y with some parameters, and we get this. So just copy this, use it here, y here. We got x train, x test, y train, y test. So let's take that and put it here. So we will need to change the contract of our function here. It will start breaking at two places, our functional test and our unit test for this function. So let's just fix the test one by one and get it to work. Let's make it work for this first, and then we'll come and change it for here. All right. So the contract of this train model will now take in, let's rename our variables. So our IDEs helpfully taught us that this capital Y train is not defined. It's an undefined variable. So we can use it here. And now we have this X test and Y test, which we don't use at the moment. So now when we will fit on this, and we will test on the test data set. Okay, now let's do the same for here, because it's saying this accuracy for KNN is not defined. That's because I had commented this out. Let's pass it in here. And we had changed the implementation. So in our test here, line 11, we will also need to pass in the X test and Y test. So I can just use something like this. And our IDE has helpfully told us that we have a missing comma here. It's something that you will not get in the notebook. Okay, the order is wrong as well. So in the original code, I have put x, y, x, y. But in the function now, it is x, x, and y, y. So let's put it in the right place. And I knew this from the test description. The test output is saying that the input shape is bad, so I suspected that this wasn't in the right place. Let's review our commit.
Right, now we've improved the train model function to validate on validation dataset. Update the test case and fix the bug here from 0.98 to 99. And we train test case here. So we make our train model function
score the model on validation set instead of the training set. Let's close everything. And this is the end of the video. We've gone from a pretty hard to read Jupyter notebook into a code base that reads like a story and that is covered by unit tests. And should there be any degradation, if I should accidentally break anything, the test would give us immediate feedback to know that I've done something wrong. And that's what you get from this refactoring process. We've gone through the refactoring process, my refactoring process, from the prerequisites, the setup, to make sure everything works and that you become productive as a data scientist, to converting from a notebook to a Python file so that you can use the keyboard shortcuts to move things around, rename variables easily. We determine the boundaries or refactoring and added a characterization test, and I hope that through the demo you saw how useful the characterization test was. Every time we forgot to change something or we broke something, immediately within 2 or 3 seconds or even less, it tells us that, hey, something's wrong, fix that before you go on. And the kind of immediate feedback is what helps to reduce bugs and errors and helps you to make sure your code is always in a good state. We've gone through the refactoring cycle. Maybe it looks nicer in this diagram. Yeah, we extract a block of code, write a test, make it pass, replace that long-winded implementation detail with this single function. And if you're doing this exercise in a Jupyter notebook, you would restart and run the entire thing. Or if you did what we did in this video and we wrote a characterization test, then this is kind of done continuously as you go. And we commit our changes so that we reduce the number of work in progress at one time. And it manages our mental load and make sure that we always have a kind of clean slate to focus on the actual task at hand rather than the 5 other problems that we were solving before. And at this point, you can also add a functional test for your machine learning model. We had already done the skeleton of the test here. 50 is just a very low bar, but for your use case, you would set it to the accuracy threshold that you can stomach. So what does it mean for this model to be good enough? Does it need to be 99% accurate to be good enough for production? Does it need to be just 90% good enough? And now we're using just the plain accuracy score. You can be more nuanced and use precision, recall, whatever for you determines that the model is fit for production. You would write a test for that here. And now we've done everything and we can celebrate. I hope you enjoyed this video, and feel free to comment below and let me know how this has helped you or how this could be improved and what else you would like to see in this video series. Thank you.